Welcome to the Beneski Museum of Natural History at Amherst College. We're about to take a tour with Dr. Stan Rachootin of Mount Holyoke College. Stan began working at Mount Holyoke in 1984 and over decades has taught numerous classes on Darwin's work. Today he's going to take us on a tour of some of the key elements of the Beneski collection.
Okay, so who here did a review of the literature on Smilodon? No one? Did anybody do Smilodon for the Fossil Lab? There's always someone who's done Smilodon. Nobody did Saber-tooth for... Okay. You are a unique group for this class because somebody's always doing the Saber-tooth. Can you get them together? Okay. Are you taking this pass-fail? What?
You know how gullible I am when it comes to...
Still? This is the last class, second to last day of class.
Very trusting.
Oh. I'm here to protect you. Okay, Smilodon. So huge canines. An amazing gape, since this is all wired together. We're not going to open it, but remember the one we had in lab. You could really open it up. You have to clear that to use that tooth. And there are other parts of the same story. This crest up here is for a massive muscle which goes through the under the zygomatic arch and here to attach into this big depression here, so you'll have a really powerful muscle for pulling up your lower jaw. And huge processes here on the neck because you have to steady this skull once that saber is in play, and you don't want things wiggling around because this is a permanent tooth. It does not grow back. If you break it, you bought it, or you lost it actually. And there are a fair number of injured saber-toothed cats preserved at Rancho La Brea in Los Angeles, which is where this one came from. Has anyone ever been to Rancho La Brea? Me too. Anybody else from Los Angeles? Me too. Condolences. Long Beach though, right? That's more civilized. Okay, yeah. Rancho La Brea is the one good thing about Los Angeles, actually, but it's well worth seeing if you ever have to go there. And here, back in the realm of premolars and molars, we are getting very sharp, because here we're not using molars for crushing, we're using molars for slicing meat. And so, same teeth, but now we've moved the cutting function back to where you're getting your best force, your best force out of a second degree lever at that back part for slicing flesh. Very interestingly, in the lower teeth here, these are all incisors in the middle, but that at the end and that at that end, those are the lower canines which have been pulled into the field of the incisors. And that's part of the story. These massive muscles back here and here are part of the story, and these are part of the story. Now, in the old museum, the old version of this museum, which was larger and in the main quad of Amherst College, they had, standing quite close to the Smilodon, a lion skeleton. And that was about the same size overall, but much more graceful, longer metacarpals here, thinner fingers. You still don't want to mess with a lion, but they were going for speed. This is going for strength. So how do big cats today, how does a lion or a leopard kill its prey? If one of you can play lion, the other one can play wildebeest. What is the lion going to do to the wildebeest to kill it?
Like that, and pounce it, and then...
Sorry?
Pounce and then tear its...
Pounce and tear where?
In the neck.
Okay, oftentimes you'll choke it, you'll grab it around the neck, or sometimes you can just grab it around the snout. And generally, if a wildebeest suddenly discovers that instead of a little ring through its nostrils, it has a lion through its nostrils, you go into shock and die. You might just die of that. But if not, you're going to be suffocated by the lion holding your mouth shut. Okay, so these are ways to die with if you happen to apply a lion to yourself, but that's not going to work here. The last place you'd ever want to put that is into a neck, because necks have vertebrae with all those processes coming off of them, and you have these really big tubing, the eustachian tube, the larynx, the trachea, really big blood vessels, lots of stuff that you could just catch on and break. And if you break, this is you don't want this to be a use once, throw away sort of thing, because you only have 2 of them, and it'd probably be good to have more than 2 meals in your life before you call it quits. There are some that are found with one of them broken, and that has suggested to some people that they were probably living in family groups, and that the rest of the family group will look after you if you can't really use your saber-tooth for hunting anymore because you've broken it, or used one of them for that. In terms of what they were probably doing, if you're not going for the neck, where else could you be going for? The feet. No. Look at all the bones you have of the feet. What would you do with a saber? Pedicure. What are you going to do with a saber and the feet?
Pierce them so they can't run. I don't know.
Yeah. No. Anything else?
The underside.
The soft underbelly, yes, a great place. So what you could do is possibly just by lying in wait and getting ready to pounce up on your prey, grab it, steady it with those really massive, strong claws, bite in here and make the hole, put in a saber and slit, and then your guts fall out. That's probably a pretty effective way of hunting. Some people have thought they might be able to slash across the chest. Oops. And the microphone. Okay. Sorry. Back in the pocket, through the washing machine. That's another possibility that some people have thought it could work. Slashing across here, if you can stay away from ribs and stuff like that, might also work. And then you would just bleed to death. But it's a different way of hunting and a different way than any cat is doing it today. If anybody of you looked at the specimens that we had around Smilodon, we also had a specimen of Neophilus, the clouded leopard, which is a skull only about this big. Really big canines at the top, but really big canines below too. Not that big, but noticeably large. And we don't know what they're doing, and they're alive. We thought maybe it's for grabbing birds through all the feathers and holding them, but they don't do that. That we know. So we're clueless of what they're doing with it, and they're a live thing. So it gives you some sense of why we can be sort of humble about figuring out what's going on with Smilodon. Over here we have the dire wolf, which is quite closely related to the living wolves, but again larger, more elongate metacarpals. But it's still a running animal, but again it's a stronger running animal. So it's again going for strength over speed because its prey are bigger and slower, so it doesn't have to be as fast. One of the interesting things about this is that, okay, remember back in the allometry lab, I told you about taking the area of the foramen magnum and graphing that against the mass of the animal. So this was originally done in the 1960s by someone named Harry Jerrison, and he was a paleoneurologist. And he wanted to figure out how the brains of extinct mammals worked. And the first thing he wanted to figure out was how much did they weigh? And since they tended not to fossilize with a little thing from the last scale they stepped on saying what their weight was, That's where the foramen magnum thing came from, because he went to museum specimens where you knew what the weight of that animal was, and you could measure the foramen magnum, and he got spectacular correlation coefficients between those two things. And then he could apply it to the fossil ones, because you would get their foramina magna too. And what he really wanted to do, though, was blow a bubble of liquid latex into the cranium, let it set against the inside of the cranium, deflate it, pull it out through the foramen magnum, blow it up again, and he could see what the brain had looked like. And one of the things he found in these is that all the canids that have packs, or sometimes have quasi-packs like coyotes, have an extra little lobe in their brain which correlates perfectly with we have packs. And all the foxes, which are solitary, don't have it. And of course, this being a wolf, it has it. So we can tell, looking at its brain, that it had the brain of a pack animal, which we sort of assumed anyway. But that was, it's neat to see that we can actually do a kind of paleoneurology. One of the other things, sorry, yes?
How did they know that it was correlated with those? Like, it could have been like a...
Because we have hunting dogs. We have all sorts of dogs today that are solitary, and a fair number of dogs today that run around in packs. And all the ones that have packs have the same lobe coming off of one part of their brain. And so this is sort of like internal phrenology, but at some point phrenology will work if you get close enough to the brain. The other thing that Jerrison found was that looking at river otters know that there's a fish around because their vibrissae coming off around their mouth feel the fish passing, and they go and snap at it. And so they have a brain representation, like you have a little homunculus in your brain with big lips and big fingers, because those are the parts that are particularly sensitive on you, and a lot of the rest of your body sort of goes away to almost nothing because you don't have as many neurons there. So they would have a really big sort of cheek in front of their face region where all their vibrissae are. The nerves for the vibrissae are going to the brain. But in a sea otter, it's feeling on the bottom with its hands. So it has giant hands, or front paws in its brain, and its vibrissae are really not showing up much at all. So you can figure out a lot about the brains of the animals from just looking at these latex balloons that are blown up in their brain. But it was done to figure out figure out some more about what's going on in the minds of completely extinct mammals.